Back to another video, guys. It's all about 2D shapes. I prepared combined questions about that. And this is exam styles questions for GCSE and iGCSE, and you are on revision with Daniel Dallas. All right, let's get started. Pause the video, try to do by your own, and let's have a look at my explanations. All right, so the first question is all about finding angles of triangle AMCD. Here is the small triangle here. As you can see, it's arranged by extending the side AD towards until it will intersect with the line segment CM at some angle. And we need to figure out all angles. So I mark all the angles. In that case, let's change the color for angles. And I put angle Y, angle X, and let's say angle at the corner or at the vertex D, let's say Z, all right? So we are supposed to find all three angles. How we can do that? Because we are given triangle BCD as equilateral, so the keyword here equilateral, and also reflected about horizontal line segment BD. So if this line segment, it has been reflected downwards, so obviously we'll get the same triangle but flipped over. Because according to the property of the triangle, we have this angle 60, and each angle at the corner is going to be also 60. So the same triangle will have in the bottom part. So this key angle is also 60 degrees. So the first candidate for finding is angle Z, all right? So what I'm going to do, I'm just going to squeeze a little bit. Okay, and now we have plenty of space. Let's have a look at the angle D, which is open angle. So let's have a look at the angle ADM. Its measure is 180 degrees, and it's arranged by the summation of 60 degrees and now the 60 here and here, and angle Z. So from there we can figure out the value for Z. All right, so it's 180 minus 120. That will deliver us the value for Z. So finally, Z angle is 60 degrees. Okay, so we found the first candidate, and we also need to find angle Y. All right, so how to find angle Y? We are given the ratio angle MCD to BCD. So MCD is angle Y, so this is angle Y, and BCD is angle 60 degrees because this is the angle in the equilateral triangle. All right, so let's build out this ratio. I prefer using a fraction, so that means because it's easier to resolve this fractional equation. All right, so let's resolve crisscross, but I'm just going to transfer only 60 to 1 in order to figure out y value is going to be 60 over 3. That means we've got angle y to be 20 degrees, and we found one more angle. All right, so the x angle can be found by subtracting all those two from 180 degrees. So that means it's 180 minus z plus y. All right, so that means angle x finally is going to be 180 minus the sum will give you 80 degrees. And that means we can find this angle x as being equal to 100 degrees. All right, so we accomplished A, and it's done. And let's move on to B part. So in B part, the question is all about reflection. So let's have a look at that. So I just squeeze that. And also I want to shift. All right, this way, that's good. So in question B, what we need to do, we need to reflect point M about vertical line segment AC. All right, so let's connect with dashed line, and let be red one. It's going to be dashed line, vertical line. Let's connect points C and A. So right this way. So that's going to be vertical line segment that goes through 2 points. Okay, it goes through point C and through point A. Okay, what we'll have the image. So let's have a look at that. The image of the point M becomes point M star. Okay, I squeezed pretty enough. Let's put it down here. All right, so how to build up the image? You understand that the distance from point M is going to be the same as the distance, the distance from point M to the line segment AC, basically to the mirror, is going to be the same as the distance to point M star from that segment. That's going to be the image. So that means if you prolong in the same way line segment AB and this way until you'll intersect with this dashed line that goes through M perpendicular to AC, to the mirror, and way far back on the outer side of the line segment AC, you'll get exactly M star. That's how you can build up reflection. What you need to do, you need to arrange the shape A, M, C, M star, A, M, C, and M star. So, okay, that's definitely quadrilateral because there are 4 vertices and 4 sides. So you need to give the name for this shape. All right, so because basically we reflect segment CM and segment MA along or about the line segment AC where we put the mirror, we'll get a symmetrical part, and because this part arranged in the way so that basically line segment CM is equivalent to M star C, and also line segment AM is equal to line segment M star A, okay, we arrange a kite. So this shape is called kite. So we've got a kite finally. And I hope you understand why is that so, and how reflection works. So that was transformation, what is called reflection in this particular case. Don't forget to watch other videos about transformation geometry. It's very significant. You'll find rotation, you'll find reflection as well. Translation as a basic transformation. Using vector of translation, you can basically translate the shape, and that's very useful. All right, and also scaling. Scaling procedure is pretty well familiar to you, and it occurs in problems dedicated to 2D shapes when one shape is scaled up or scaled down. All right, hope you like that. If you're new here, don't forget to subscribe. Thank you guys for your support, and just we keep going.